our next group here is capitalizing on a similar theme, but in more detail, building a smart home. So whoever's talking, you got to get right here. And if you're taller, move it like that so they can hear you. Otherwise, people can't hear you and the recording can't hear you. Okay. Cool. So yeah, as much as you just...
Yeah. Hello everyone, how are you all doing today? Good. My name is Awa, and I'm here to present with my teammates. We are here to present about home automation, and here I present to you Colin Redmond. We have Brian Curtis, and we have Dean Nelson here today. And as you may know, our lifestyles are changing day after day. We're trying to build a smarter environment and apply it to our home and lifestyle. So we decided to focus on in 4 areas. The first one, which I'll be talking about, is about light switch on and off using a command. And the second one, which Brian will be presenting, is about laundry machine sensor. The third one would be about, Dean is presenting about it, and it's an irrigation system, automated irrigation system, and everything would be integrated inside a server called openHAB, using openHAB, and that's what Colin will be presenting today. So to start with home automation, which go to the light switch. Yeah, no, this one is fine. Yep. So here as I said before, we're trying to. Okay. We always have those moments where we walk into the house and bump into stuff just to get to the light switch and turn it on and off, or we're just sitting in our couch and we don't want to turn off the light and it's too far. So that's everything is going back to energy consumption. And I decided to work on this project because I feel like it's something that I'm using every day. And if you go to the next one, here are the parts that I needed to complete this project. And as you may see, we're using Arduino Uno. We're using a relay, a Bluetooth module, a breadboard, the Android app called AMR Voice, and some wires. So it's a fairly simple system, but it's very useful when everything is put together. So the first thing I've done was to pair the Android app to the Bluetooth module. And after that was done, I powered up, I first powered up the Bluetooth module, of course, and I powered up the Arduino Uno and the relay. From there, I inserted some code into the Arduino Uno just to tell the relay to switch on and off once I use the application to say switch on and switch off. And that's what I've been working on. So now I will give it to Brian to present his power of the project.
Hi. So have you ever been in a situation, maybe in college or maybe if you're at a laundromat or something, where you were doing laundry and they had to be done in it was going to be done in 40 minutes, but you just lost track of it, and now your clothes maybe have gone sour, or maybe someone else has moved them to use a washing machine? Well, I'm working on a sensor that can tell you when your washing machine's done. So when I first started working on this project, I thought about how I could actually sense whether or not I was done. And what I like to do when I think about that is the 5 senses, the eyes, from sight, touch, smell, hearing, and taste. And obviously, taste or smell would have to do with chemicals, and that would be too expensive or complicated to work on. So I looked at touch, sight, and sound. Now, for sight, I wanted to use a laser, but I couldn't find one. And for touch and sound, I ended up using a microphone and accelerometer. Next slide. So my parts included using an Arduino Mega as a base, an accelerometer, a resistor, a microphone, a mini breadboard, a blue LED, 5 wires, and a battery pack to power it. The next slide. And my code was based around 3 parts after the introduction. A part to listen for noise, the accelerometer, and a code function to determine whether or not to send a signal. The way the sound works is if there is no noise, it sends a false signal that the Arduino stores. The way the accelerometer works is if it detects values that are registered to be like, standard non-moving values, it sends a false signal to the Arduino. And the third part is if it detects false from both sources, it'll send a signal out to the server or a light bulb or phone or whatever's hooked up to it. I hope that maybe in the future, because I want to keep working on this, that I can set up a way that you can default the settings. So maybe if you're like on a hill or something, it might be different. And I'm also thinking about putting this on different devices. So a dryer, for example, a dishwashing machine. I had an idea maybe if you have a baby in a cradle and it's restless, if it was moving and making noise, it could alert your phone that there might be a problem. And so after that, I'm going to move the mic over to Dean.
Doesn't matter how far technology goes, homegrown food will always taste better than anything you buy in the store. But as you all can attest, we have very, very busy lives. And who frankly has time to water their plants every day to make sure it grows right? So my idea is to build an automated watering system, which this is the big thing up there. It has a humidity detector that goes into the soil, and then when the humidity in the soil reaches a certain threshold, the Arduino inside automatically kicks on the relay, which turns on the pump, which pumps water into the soil in very controlled bursts, so you do not drown your plants, because it's not fun to have a drowned plant. And now I'm going to hand it over to Colin, who handles the server.
My job mostly in this was to handle a home automation server, because if you've noticed up until now, all of our parts have been sort of their own thing, sort of insular from each other with no real mesh network, no real connectivity between anything. So what my home automation server does is it takes data from different sensor types, different devices and machinery, pulls them into the openHAB server. So say if we have, like in Dean's project, there's temperature and humidity, I could pull both of those values in and then run a rules engine to make openHAB do different things, kick relays on and off, display information to a sitemap, et cetera, et cetera. Next slide. And here you see pictured the server running, pulling data in, and also what it looks like in Windows. The nice thing about openHAB is that it runs entirely on Java and is not dependent on any operating system. So long as your operating system runs Java, it will run openHAB. Part of the reason I wanted to use this on Windows is because for some reason the openHAB community is very, very in love with the idea of putting openHAB on Linux machines, but it's entirely possible to use it on Windows. That's what the openHAB designer looks like. And again, openHAB runs entirely Java code. So if you're anything familiar with Java, you could just jump straight into openHAB. They have a very, very strong community. So there's a slight learning curve, but overall openHAB was very easy to pick up. And another strength of openHAB is that it runs very strong compatibility with a vast array of different kinds of sensors. So let's say I want to connect to a Bluetooth module and pull data in from that Bluetooth module and display it in openHAB. All I'd have to do is define a Bluetooth item and do something that openHAB calls binding, which is taking a physical device on your machine and telling openHAB to look for that device on that port for that kind of device. So I could say item, Bluetooth, and then I would give it sitemap information and then point it at the address of the other Bluetooth module in the setup, and it would just pull the data in and read it. And that's the end of our presentation.
So house proud, nothing ever slows her down, and a mess is not allowed.